is rational exponents, and I should have thrown in there, and radicals. Rational exponents and radicals. So in math, whenever you hear this word rational, a rational number is a number that can be written as a fraction. So a rational exponent, it's just a exponent that's a fraction. Okay? Now, what we are going to be doing is we're going to be going back and forth from rational exponents into a radical. Okay? So, on your little handout here, it says a rational exponent, it usually refers to a power that has a fraction as an exponent. Usually has a fraction as an exponent. What we can do, like I mentioned, is we are going to learn today how to go back and forth between the rational exponents. We're going to turn it into a radical. Now, radical may not be a word that maybe you've heard before but aren't quite sure what it is. A radical is more commonly called a square root. That's probably what you have called it in the past. This symbol right down here. Now, the reason why we're not going to always call it a square root is a specific type of radical. So kind of like you could have x squared. We could say, well, you could square a number. That's an exponent. But that's not the only kind of exponent you can have on a number. A radical, okay, is a lot of times a square root, but it's not always a square root. So let's talk first about the parts of a radical. So in the radical, okay, we're going to have two numbers here for the most part today. Sometimes you won't, but most of the time we will. So this number right here, the 4, okay, well that's easy. This is x to the 4th. That's the exponent. It's just an exponent. It's a power underneath the radical sign, but it's still an exponent. Okay? Now, this number right here is the number that we probably haven't seen before, that if we have seen a square root, there's not a number there. Okay? But today, a lot of times there is going to be a number here. This number is called the index. The index. Now, in math, a lot of times we talk about opposites, like if you're adding, the opposite of adding is subtracting. If you're multiplying, the opposite of multiplying is dividing. It turns out that an exponent and a radical, they're opposites of each other. They're inverses in a way. So what I mean by that, if you took 5 squared, okay, or 5 times 5, you would get 25. So then if you take the square root of 25, what it's asking you is what number times itself 2 times gives you 25, and you would say 5. What number times itself 2 times? Since this is a square root, what number squared gives you 25? Now, we know that I don't have to do 5 squared. I could do 5 cubed. Well, 5 cubed, 5 times 5 times 5 is 125. So the opposite of cubing something would be to do what's called taking the cubed root of something. So if I want to take the cubed root of 125, what I'm asking is what number cubed would give me 125? Well, 5 times 5 times 5. We just did that. So the exponents and the radicals, they're opposite of each other. So we can use that idea to simplify some of these here. So if I want to take the cubed root of 27, I would be asking myself, what number cubed would give me 27? Remember, sometimes, what number times itself? Some of these might be kind of hard to think about. So if you just kind of go through the numbers, if I do 2 times 2 times 2, you get 8. If I do 3 times 3 times 3, what do I get? Times 3 times 3. What do I it? 3 times 3 times 3. 3 times 3. 9 times 3. 27. See that? So the answer to this would be 3. Because you take 3 cubed, you get 27. Now this one here is saying what number to the 5th. This is saying I want to find the 5th root of 32. So what number to the 5th power, what times what times what times what times what 5 times would give you 32? Some of these are just going to have to try some numbers, right? If I take, and I'm starting with small numbers, right? 2. 2 times 2 times 2 times 2 times 2. Guess what that gives you? 32. Yeah. So the 5th root of 32 is 2. That's one of the things we're going to be doing today is simplifying radicals. Now, one of the other things we're doing today is we're going to learn how to go from a radical into a rational exponent. So this is pretty simple to do. I think the simplifying part is harder than this. Now remember, we had the two parts of a radical. We have the exponent. And then remember, the little number on the outside was called the index. Now to go from a radical to a rational exponent, okay, you're going to take the number that's underneath the radical, the x. This is going to be the base of your power, okay? So if it's the square root or 4th root or 5th root or whatever root of x, x is going to be your base. So it's going to be x to the, I need to figure out what I'm going to put in my fraction. So what you're going to put in your fraction is you are going to put the exponent, you're going to put the exponent over the index. Exponent over index, okay? And how I've seen places do that is they just say exponent over index. How you can remember this is you just think about EOI. EOI, exponent over index. That's what your fraction is going to be. Exponent over index. And you could go back the other direction. If you have a rational exponent to write it as a radical, you take your base, throw it underneath the radical sign, and then you have exponent over index. Okay? All right, let's get this glued into, should be, not that page, this one, here we go, page 6. This is section 7.5, and it is rational exponents and radicals. All right, so we're going to do a few different things today. We're going to simplify some radicals, and then we'll go back and forth between the rational exponents and the radicals. So let's start by simplifying some radicals. So number one, if I want to find the value of the square root of 49, I forgot to mention this whenever you're going over the left-hand side. We talked about how you have the two things, you have the exponent and the index. There's obviously not an exponent here because it's just 49. But on this one, there's also not an index. And this gets kind of confusing because usually I'm like, okay, if you don't see a number, right, if there's not a number in front of the x, you know it's a 1. And if you don't see an exponent, it's a 1. So in those cases, yes, if it's an invisible 1, we just don't normally write it. With a radical, if you don't see an index, it defaults to a square root, which means the index is a 2. Okay? If there's not a number there, the index is a 2, because we would call it a square root, which means what number squared, what number times itself 2 times gives me 49. What number squared gives me 49? 7. 7 times 7 gives me 49, so the square root of 49 is 7. Okay, what about the cubed root of 27? Now if there is a number there, it means, okay, well, what number cubed, what number times itself, what number times what number times what number gives me 27? I already did this one on the left-hand side, didn't we? 3, right? 3 times 3 times 3 gives you 27. So the cubed root of 27 is just 3. Okay, what about the cubed root of 216? Now this is where you kind of have to understand what it's asking, and then really the best way to do this is just kind of guess and check. What it's asking you is what number times itself 3 times gives you 216. So we're just saying, okay, well 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. It's not that. Okay. 4 times 4 times 4, 64. And this where you just kind of guess and check. 5 times 5 times 5. What did that one? It's 125. This one, 6 times 6 times 6. This one is 216. Yeah, 6 times 6 times 6 gives me 216. So the cube root of 216 is 6. Okay, and then the fourth root of 625. Once again, if you don't know off the top of your head, you are not alone. But what you're asking is what number times itself 4 times gives you 625. Now I've already checked, well I guess that's the fourth root. So kind of think ahead here. What number can I multiply and I hit in a 5? 5, so that might be what I try, right? And guess what? 5 times 5 times 5 times 5 is what I gives you 625. So the fourth root of 625 is going to give you 5. So that's one thing you'll be doing on your homework today. Like I said, if you understand what the root means, what the index means, then it's kind of just that you're guessing and checking. Okay? Now, the other ones is where you're going to be going back and forth from rational exponents to radicals, or from radicals back to rational exponents. So this one, if I have a to the 4/5, a to the 4/5. So what I want to do here is I want to write this as a radical. So that means I'm going to have a radical, okay? Now what's going to go underneath your radical is the base. So my base here is the a. Then you have to decide where you're going to put the 4 and the 5. So this is where that EOI comes from. EOI. The 4 is your exponent. So that means this is going to be a to the 4th. The I is your index. So it means it's going to be a 5th root. We'll look like that. Now you do need to be really careful here, because if I have 9x to the 2/3, 9x to the 2/3. Now I want to write this as a radical, but you have to be really careful here, because what goes underneath the radical is the base. And if you remember from last week, I told you a lot last week that the exponent only applies to the number right underneath it. So what's my base here? X. Just the x. The 9 isn't part of the base, so the 9 isn't going to go underneath the radical. The 9 is going to stay on the outside. And then you're going to look at your fraction, and we have exponent over index. So it's going to be x squared, and it's going to be a cubed root. So it'd be 9 cubed roots of x squared. Okay, and then number 7. Now, if I had something like this, 36b in parentheses to the 1/2. Now, this one's different. Whenever I'm deciding what I'm going to put underneath my radical sign, this time there's parentheses, which changes things. What's my base here? All of it, yeah. Because this is raising whatever's in those parentheses to the 1/2 power. So we're going to put the 36b, the whole thing under the parentheses. Okay? And then we're going to do exponents to the first power, which just stays the same. And then my index is going to be a 2. Now, here's the tricky part today, is sometimes you're going to write your answer, and it's not actually your answer. Because I can simplify this. I can take the square root of 36. What's the square root of 36? What number times itself? 6. Yeah. So what you're going to do here, I can take the square root of 36. It's 6. Here's the problem. I can't take the square root of b, because I don't know what b is. So the b is actually going to stay under the radical. Now, if you want to write the 2 for your index, you definitely can, but you don't have to. If you did, it wouldn't be wrong. If you did, it wouldn't be wrong either. But it would be 6 square roots of b. Okay, number 8, let's say we have in parentheses 64x squared to the 1/3 power. Super similar to the last one, right? We have our radical. What's going to go underneath the radical? Everything. 64x squared. And then we have exponent, which is a 1. The exponent of 1 isn't going to change anything, so it'd probably be simpler not to write it. And my index here is 3. Now what you need to do is, before you circle and box your answer, if you have a radical, what you need to do is say, okay, can I take the cubed root of 64? Is there something times itself 3 times it gives me 64? And once again, if you don't know these off the top of your head, you probably don't. That's totally fine. But you would need to check. I know it's not 2, because 2 times 2 times 2 is 8. I know it's not 3, because 3 times 3 times 3 is 27. But 4 times 4 times 4, 16 times 4, gives me 64. So remember, the cubed root of 64 is 4. But, kind of like here, I said you can't take the square root of b because you don't know what b is. I can't take the cubed root of x squared because I don't know what x is. So we're going to leave that as the cubed root of x squared. So it'd be 4 cubed roots of x squared. Okay, now the next one, we're just going to go the opposite direction. We're going to go from a radical into a rational exponent. Okay, number 9. The 4th root of a. Okay, so what you're going to do, just the opposite. Whatever's underneath the radical, that's your base. So it's going to be a to the, then I've got to figure out what that fraction is going to be. So it's going to be, right, exponent over index. Now, when you look at the a, I don't see an exponent. If we don't see an exponent, what is it? It's a 1. So it'd be exponent over index. So 1 over 4, a to the 1/4. Okay, number 10. The cubed root of 8x to the 4th. Okay, now for this one, what you need to do before you take it out of radical form, if you have a number under the radical sign, you need to check and see if you can simplify that radical. Can you take the cubed root of 8? There's something times itself. What times itself 3 times? 2. 2 times 2 times 2 gives you 8. So the 2, the cubed root of 8 is 2. But, like we said before, you can't take the cubed root of x to the 4th because you don't know what x is. So we're going to leave that as the cubed root of x to the 4th. So we simplified our number. Now we need to take this and write it as a radical. Now remember, the 2 is just going to stay a 2. But the x, what's underneath the radical sign, that's going to be your base. And then we do EOI, exponent over index, 4 over 3. Okay, a couple more of these. Number 11, the square root of 64W. Remember, before you take it out of radical form, you need to check if you can simplify. Can you take the square root of 64? What is the square root of 64? times what? 8. So it's going to be 8. Remember, you can't take the square root of w, so we're going to leave it as the square root of w. So when you then take this into radical form, it's going to be 8. The base of your power is w. Now, here's where this gets a little tricky, is because you have to do exponent over index. I don't see an exponent, so what is it? 1. Careful here. I don't see an index. It's a 2, right? Because it's a square root. So it would be 8w to the 1 half. Okay, and number 12, last one of these. Let's do in parentheses, the square root, and then in parentheses, 9x, the whole thing to the 4th. Now this is one where I wouldn't necessarily go ahead and take the square root of 9, because here's the thing, it's not actually a 9, right? It's a 9 to the 4th. So on this one, I might not worry about taking the square root of 9. Once again, it's not a 9. I might go ahead and just write this as a power, okay? So my base, remember, is whatever's underneath the parentheses, that 9x. Since it's in parentheses, we're going to do exponent over index. What's my index? It's going to be 4 over 2. What is 4 over 2? 2. 2 over 1, 2. So it's going to be 9x squared, which we can square the 9, and we can square the x, the 81x squared. Okay, now the last couple ones are going to take kind of all of the stuff we've talked about so far in chapter 7, along with this, and tie it all together. So number 13, in parentheses, a to the 1/4 times a to the 3/4. Okay, so we want to simplify and then we want to write it in radical form. Now with this one, I know I've got these fractional exponents that look super confusing because we love fractions so much, but if this said a to the 4th times a cubed, if it looked like that, what would you do with the 4 and the 3? You'd add them. Well, if you would add these exponents, you're going to add these exponents. You do the same thing. Now, we're adding fractions, which means they have to have a common denominator. Luckily, they already do. So it's going to be a to the, right, you add the numerators. 3 plus 1 is 4. Do you remember what you do with the denominators? We add fractions. What do you do with the denominators? You have a 1/4 of a pizza and 3/4 of a pizza. You have 4/4 of a pizza. You keep the denominator the same. When you add fractions, you keep the denominator the same. So 4 over 4 would be 1, so it'd be a to the 1st, or just a. Okay, number 14. What if we do b to the 2/7 times b to the 4/7. Okay, same idea here. If you would add these exponents down here, you're going to add these exponents up here. They are fractions. Luckily, once again, they have a common denominator. So we're going to add the numerators. It's going to be b to the 2 plus 4 is 6. Keep the denominator the same. So it's going to be b to the 6/7. Now the directions say write in radical form. So then we're going to write a radical. The b goes underneath the radical sign. And then remember, it's exponent over index. So it's going to be b to the 6th, and it's going to be the 7th. Okay, last one. Number 15. All right, in parentheses, x, y to the 1/4, and then x to the 3/4. Okay, keep in mind these exponent rules. If this said xy squared, hopefully we would remember that it means you have to square everything inside of there. It's the same thing if you're want to take everything in here to the 1/4 power. So it's going to be x to the 1/4, y to the 1/4, and then this is just going to say x to the 3/4. Now remember, we can only multiply powers that have this same base. So I can take x to the 1/4 times x to the 3/4. Do the same thing. We're going to add the exponents. 1 plus 3 is 4. Keep the denominator the same, so it's going to be x to the 4/4. And then this is just going to say y to the 1/4. Now what is 4/4? Just 1. So this is going to be a 1. So this technically doesn't have a rational exponent, but this does. So be really careful here. When you're writing your radical, the only thing that goes underneath the radical sign are the powers with a rational exponent. What's going to go underneath the radical sign? Just the y, right? The x doesn't have a rational exponent. And then we're going to do exponent, which is a 1. You can write it, but you don't have to. Over index, it's going to be x 4/3 of